So today I'll be covering some best practices for testing. A bit of introduction first. My name is Tania, and I'm a developer at Thoughtworks. Thoughtworks is a consulting company. We do mostly software development for clients. So this is my first time here actually. So I want to know the background of the people here. Are you project managers? Are you developers? Who are the project managers? None? Oh, okay. And developers? Okay, so most are developers. And what else? Anyone else? Did I miss anyone?
It's developer also.
Okay, cool. Right, so if we think about what we're trying to achieve by testing, what is it? What do you have in mind when you're spending effort in testing? Anyone?
Validation bugs.
Sorry? Validation. Bugs. Yes, reduce bugs. Okay, yep. And then, anything else?
Confidence.
Confidence. Okay, so one way to think about writing tests is to think about it as building a bug detector along with your actual application. And in other words, it's like building a self-testing code, right? You're building an application or code that is able to test itself, that is able to know whether it's healthy or not, whether it's full of bugs or not. And what does this give us? It gives us confidence. It gives developers confidence in changing things, whether it's fixing existing bugs or whether it's implementing a new feature. And it gives reduced defects. So because we are implementing a bug detector, it should detect some bugs, right? So it should help us find some defects. And it should be a living documentation. The test should contain everything that is expected of the system, everything that we want the system to behave. And so it will be living documentation, not just something that you write and then probably, unfortunately, forget to update. And then it should give defect localization. What do I mean by this? I mean, when you run your test and you see that maybe 10 tests are failing, by looking at the tests that are failing, you should have some idea where the problem is. Just looking at the tests that are failing. And the tests themselves should be robust in the sense that just like we expect them to be bug detectors, so they should detect bugs and nothing else. They should not start breaking because of things that are not bugs. For example, if you move your button or if you rename your button, it shouldn't break. Okay. So how do we achieve self-testing code? Let's go over some fundamentals first. One is don't get fixated on test coverage. I find that some people, when they first go into testing, they think that at the higher test coverage, the better. And they try to go for maybe 100% or 80% test coverage. And this often gets tricky because like any matrix that is set as a KPI, it sometimes motivates people to achieve this matrix without thinking really about what is good to do. And the other thing is that for code, 100% test coverage is not necessarily better than 60% test coverage. Because often when you're testing, you're not inventing new things. You're often using libraries, right? You're depending on the language features. And if you do 100% test coverage, that means you're testing things that actually don't quite need to be tested. Like, for example, Java getters and setters. These are arguable, but that's my opinion on this, that these things do need to be tested. And yeah, so going back again on building a bug detector. So when you see a bug, you should add tests for it. And when we think of this in a test-driven development way of developing things, when you see a bug, you should write the test for it, you run it, you see it failed, and then you fix it, run the test again and see it passing. And the test should be run frequently. There are many kinds of tests, and they should be run in various frequencies. but in general, they should be run frequently. How frequently? For the fast tests, the developer should be running them once in a few minutes, or once before every commit at least. And also, if your team has a continuous integration server, then this test should be run in the continuous integration server as well. And this is the background of the set of the new Star Trek movie, because it's all computer graphics. But wow, what I really wanted to say was that the tests, you don't just need to run them frequently, you need to keep them green. Why is that? Because not keeping them green reduces your own trust in your test, and that is dangerous, because when you and the team starts having less and less confidence in your test, you don't care about it anymore, and it doesn't give you the benefit of telling you which the problems are in your code. So yeah, sometimes when there's deadline looming over you, and there's a lot of things to do, and there's some tests failing, it is a bit there's a bit of temptation in letting some tests keep failing, or even commenting them out. But yeah, again, this reduces your own confidence in your test, and it is detrimental in the long run. And the next thing is include tests in your definition of done, in the sense that developers, when they are developing things, when they're developing a feature, they shouldn't say that I'm done with this before they write the test and make it pass. And it's also a team effort. So if only one person is writing the test and making it pass, and the other team members don't add the bugs that they see in the test, not the bugs, but verification that the bugs don't exist in the test, then there isn't really much benefit in doing this. So it should be a team effort. So how do we achieve self-testing code? Let's look at some of the different types of tests. Yeah, first, looking at a bird's eye view of a typical system. Say the orange nodes here are a component, talking to some other components, and some of them in the end talk to some database. And some of these nodes will expose some kind of user interface, probably a website, a web application, or a desktop one. So UI tests are tests that are driven from the user interface layer. So you can think of it as like a robot user. You can script UI tools, UI testing tools to click around in your application and type things automatically, and then verify that certain things are shown or certain things are not shown in your application. And then there is surface layer test. In this example, I assume that the orange node there is exposing a RESTful web service. So in this case, the surface layers test will be something like this. This is the get subscriber one. That is the request, the HTTP request. And then it gets the response and verifies that the response matches the expectation. So yeah. So in surface layer test, there are many classes and methods inside that component that are interacting together to then give back the response. Of course, this particular example is a very simple one, but generally, in every component, there will be a lot of classes working together. And then we have unit tests, where we test a particular unit on its own. But the somewhat tricky thing here is that the definition of unit is up to you. It can be a method, it can be a class, it can be a collection of them working together to achieve something that's common. So how much of this test do we need? Typically, we will say that unit tests, you should have the most amount of them. Why? Because first, unit tests are typically fast. When done correctly, they are fast. And they since they test each unit independently, they give you a lot better defect localization. Again, defect localization is such that if you see the list of tests that are failing, you know what the problem is roughly. Whereas service and UI tests, they are more like integration tests. So when you see something failing, there are many points of failure. It's a lot harder to find which one is causing the problem. So going over some terminologies first. Let's say that we have a feature whereby we are trying to send email reminders to people, to subscribers whose subscriptions are due in 7 days. So we have a test here, the subscription fee reminder test, and it's trying to test this subscription fee reminder class, which in turn uses two classes, email sender to actually send the email, and subscriber repository to get the list of subscribers and to get the data of the subscribers. So the subscription fee reminder class over here is often called the system under test, or SUT. And the email sender and subscriber repository classes here, they're often called collaborators or dependencies. And going one level down, if you look at a single test case in the test class, which is this, sorry, it's a little small, test reminder should be sent to customers due in 7 days. Then the call to the send reminder method in subscription fee reminder is often called exercising the SUT, exercising the system under test. And of course, again, we still have the collaborators. Right, and there are two schools of thoughts when it comes to unit test. One is classic, and the other is mockist. In the classic style, you typically will check state, and I'll show you an example very soon. So classicists typically check state, and they don't necessarily isolate each unit. And again, we'll see an example of this. Whereas the mockist style, or behavior-driven development style, they typically check behavior, and they usually isolate each unit. And we'll see an example right now. I'll just switch to IntelliJ. Make this bigger. Okay, so this is the classic style. I'll show you the implementation first, because we're not doing TDD here. It's just a demonstration. Okay, so we have an order class over here. The order could be say a book, and when we ask the order to be filled, we have to pass in a warehouse. And if there is enough quantity of that item in the warehouse, then we will ask the warehouse to fill the order. Okay. And there's another method here is filled, which just returns the filled flag, which is set over here if the order is actually filled. Now the classic test would look something like this, where of course at first we will just create the order, and this is when we exercise the SUT, when we call the fill method in the order class, and we give it a warehouse, and we assert state, right, in classic style. So we just assert that the order is filled. This is a flag, and then we assert as well that the inventory of this particular item, which we asked the warehouse to fill, has decreased to 0. And then we assert another state, which is the inventory of another book, which should not have been affected by this call. Now, the other style, BDE, looks something like this. Again, at first we begin by creating the order itself, and then we mock the warehouse, so we are not using the actual warehouse. And then the benefit of using this is that you can make a call to a certain method on it, like this get inventory method, to return something that you want. In this case, 50, right? And then you actually exercise the executing by calling the fill method in the order class. And then you verify that the method fill on the warehouse has been called with certain parameters. So these are the two different schools of thought. One just uses, one just checks the states like this, and the other checks behavior. By behavior, it typically means that it's something like whether a method is called, whether it's called with the right parameters, and also there's a bit of stubbing in it as well. Stubbing is basically hard coding return results. All right, so going back to this, these two different styles are not dichotomy, they are a spectrum, so people can be somewhere in the middle. They can be checking both state and behavior at the same time. So having looked at the different kinds of tests, how do we achieve self-testing code? How do we make them help us in reducing bugs and all that? The first thing is that the test should actually test something. And this looks really simple, but I've seen cases where the tests don't have any assertions in them, and I'll give an example. Here is an example, a very simple one that just instantiates a newsletter and then calls the subscribe method. And there is no assertion except that it will fail if there's an exception thrown. So this doesn't have a success criteria. Basically, yeah, this will pass if the subscribe method doesn't throw any exception, but does it really verify something that you want the subscribe method to do? It doesn't look like it. So yeah. So it's important to make the test actually test something. And the other thing is that each unit test should ideally verify one condition per test. A good rule of thumb is just putting one assertion per test. But sometimes that is not possible because we need to put several assertions to just verify one thing. And I'll show you an example of this and why this isn't desirable. Before I go to this, actually, I'll show you the implementation first. So here we have a newsletter which subscribers can subscribe to. Well, the name here is not used. Okay, so we can subscribe and we can pass in a subscriber. And if the subscriber is not subscribed yet to this newsletter, it will actually add it to the list of subscribers. Otherwise, it will throw a duplicate subscription exception. Right. So going back to multiple conditions, there are essentially 3 tests here. The first one here, second, and third, put into one test method. And the problem with this is that if we run this and it happens to fail in the second assertion, then the third test over here will not be executed at all. Whereas if you separate this into 3 tests, I'll repeat myself. If this one fails, the test will just stop there and it won't execute this one. So you won't know whether this case is problematic or not, whether it passed or not. Whereas if you actually separate this into 3 different tests, at one glance you will see that probably both of these actually fail, or this one fails but this one is okay. So by separating tests into different methods, by the number of solutions or the number of conditions that you're checking, you help yourself achieve better defect localization. Right, going back to this, I would also recommend that in your production code you inject your dependencies, and Spring really helps a lot in this. Another example. Yep. So here's an example where I have a controller, and I'm doing dependency injection on the account service. Spring helps in auto-wiring this, so in my application configuration, I can just say that I want my account service to be this implementation. But in my test, since I'm doing dependency injection, I can pass a mock to it. Right? In this case, this account service is a mock, so it's a fake object that you can then verify things against, like this. You can ask it to return something when a certain method is called. And the next thing is use a fresh fixture. There are situations where several developers share the same test database and they run tests against that same test database, and there will be resource contention in that scenario, because when a developer is running his or her own test, other developers can't do the same thing because the test database is being used. And if the test doesn't clean up properly after itself, then everyone will have a problem running their test after that. So yeah, it will be a lot simpler if you just use a fresh fixture or a fresh context every time. I have a somewhat contrived example of this. So this is again the newsletter example. In this case, this is the before class annotation. So that means that this setup method will be called once for this class, which means that the newsletter object here is shared among these 3 different tests. And the tricky thing about this is that if I run this test, it will fail. And it will fail because when I do this, when I'm running this test, in this test, this is the first time I'm adding a subscriber, but the newsletter thing says even if they fail in the middle, they won't pollute the other test. And another thing is that if your user interface is still evolving, still changing, it's trickier to use record playback test. For example, Selenium. Selenium has 2 approaches to it. You can use the record playback plugin in your browsers, and then the problem with such tools is that they will be very specific. For example, if you have buttons in your web interface, they will probably refer to it by IDs instead of, for example, the class. And so if you change these things in your code, the test will start breaking. So if your UI is still evolving, I'd recommend to use scripted tests instead. So you can make the references to your UI items slightly more general than when using record playback tests. All right, and next, some food for thought on integration tests. Integration tests are hard to get right, and that's because, one, they are non-deterministic. Since you are involving a lot of components at once, sometimes there could be network failure in one of the components, and it makes all the tests fail, or maybe some of them. And then there are too many cases to cover. It's basically a cross product of all the different cases. So for example, if you have component A having 5 cases to cover, component B having 3 cases to cover, component C having 2 cases to cover, you have to cover 5 by 3 by 5 by 3 by 2 cases. And often your systems are a lot more complicated than that. And they are slow because they are accessing real systems, real databases, and they are a lot slower than unit tests. And since they involve a lot of components, they have poor defect localization. So you don't know where the problem is when you see the tests that are failing. So one alternative that I want to point out here is contract tests. There are 2 sides of this, so you can assume that there's a consumer and a provider. A consumer sends some request to get something from the provider, and the provider gives something back. And we can draw a line in the middle for the interface. The interface will be like, well, if you call the subscriber endpoint and give it the ID of 1, then it should give you the details, which is the name and email of a certain subscriber. A contract test, again, has 2 ways to it. On this side, it validates that the consumer fires the right request, in this case, the subscriber /1, and then it just stops out the provider. So it returns a hardcoded response of this. And the other side of it, the provider, it validates that the provider, if given this request, will give this response. So that way you cover both sides, and in every contract test, there are only 2 components involved. So it gives you better defect localization again. And it's also a lot faster because you're just involving 2 instead of many components. So the takeaway mindset, I guess, would be that you should make your test a source of truth of your system's health. All of this, including defect localization and trying to get your team together to add discovery of new bugs into the test. This is all about making your test a source of truth of your system's health. Yeah, and I have some references if some of you are interested about the integrated test that I mentioned. There's a very nice talk about it. And there are some very nice patterns on mostly unit testing on this book. Yeah, and some more. Okay, yeah, that's about it. Any